Okay, so in our last class, we discussed about organolithium compounds. So more particularly, organolithium, how the preparation of organolithium and their application in organic synthesis. More particularly, so how they will act as a base or nucleophilic agent with respect to the carbonyl compounds, means addition reactions, and then what happens when organolithium react with imines, nitriles, and isonitriles. So today we will discuss about one more reagent, okay? So that is called organoselenium compounds. So here selenium means the symbol for selenium is Se. So that means, so if there is a bond formation between the carbon and selenium, so carbon and selenium, so such compounds are called organoselenium compounds. So selenium exists in -2 oxidation state. It will also exist in +2 oxidation state. It will also exist in +4 oxidation state and +6. That means selenium is having variable oxidation states. From that, so +2 state, okay, selenium 2 is the widely available uh, uh, oxidation state of the selenium compound. So selenium compounds are nucleophilic in nature and also they are acidic in nature. So first, organoselenium is diethyl selenide. The first isolated organoselenium is diethyl selenide. So that means Se is bonded to 2-ethyl group. Okay, that is called diethyl selenide. So we will look into the few different organoselenium compounds that are available in the uh, catalog. So few examples of organoselenium compounds I will discuss in the next slide. So with this, I will go to the next slide. So look here. R SEH. Okay, R may be a alkyl group or aryl group. So what you need to remember here, SEH. SEH is called selenol. So usually organic chemists used to think that if there is a OL, so they used to think that OH may be. But in this case, there is no OH. You need to, SEH is nothing but a functional group, and its name of this functional group is called selenol. Suppose RC double bond SEH is called selenaldehyde. Okay, so this moiety is called selenaldehyde. Suppose RC double bond SC and R dash, then it's called selenoketone. Selenoketone. And suppose two oxygens are attached to the selenium, then it is called selenone. Selenone is nothing but a two oxygens are attached to a selenium, and selenium in turn it is attached to a two alkyl or aryl group. And suppose a SeO2H means something like instead of selenium, means instead of carbon, if it is a, so in the case of carboxylic acid, so instead of in the carboxylic acid functional group, instead of selenium, if instead of carbon, if it is a selenium, then it's called selenic acid. Selenic acid means RSeOOH. Suppose RSeX, then it's called alkyl selenium halide. So that means R should be alkyl one. So alkyl selenium halide, the general formula is RSeX. So let's give an entry. Right. RSeX means alkyl selenium halide. RSeR dash, selenide. Okay, that means, of course, when R and R dash is equal to ethyl group, and then it's called diethyl selenide. If R and R dash is equal to methyl, then we can say that dimethyl selenide. Of course, here what you can observe, two Se bonds are there. So then it is called diselenide. So two number, di stands for two number of selenium, and which are in form a bond with the covalent bond. So then such compounds are called diselenide. Suppose one oxygen is there. Selenium is containing one oxygen. Selenium in turn, if it is attached to a 2-alkyl group, then it's called selenoxide. Then it's called selenoxide. Suppose selenium, it is attached to a 2-halide group and 2-alkyl group. So 2-alkyl means dialkyl. Selenium, dihalide. Okay, dialkyl selenium dihalide is the name of this compound. Then here 3 halides are attached, and this will be alkyl. Alkyl selenium trihalide. Alkyl selenium trihalide is the name of this compound. And then, so look here, R, Se, R double dash. The R double dash, it indicates that it is a R1 and R2, R. So different, all three different groups, all three different one, maybe a methyl, propyl, butyl, something like that. So name of this compound is called trialkyl selenium halide. So 1, 2, 3, trialkyl selenium halide. So with this, I will go to the next slide. So next slide will give you the information about the preparation of selenium compounds. So again, preparation organoselenium compounds. So I will go to the next slide. So look here a preparation of organoselenium compounds. So this SeCl2 means selenium dichloride. Selenium dichloride, when it is treated with benzene in presence of aluminum chloride, so it will give you a tertiary compound. This tertiary compound is in turn is converted into a diphenyl selenide. So with the liberation of benzyl chloride. So let's give an entry. Right. So what is happening here? Maybe if you want to write directly from reactant of these two, this product, no problem, you can write. So diphenyl selenide is prepared by the reaction of selenium chloride and benzene in presence of aluminum chloride. Selenium chloride on treatment with benzene in presence of aluminum chloride, it gives diphenyl selenide. So diphenyl selenide is a organoselenium compound. This is an example. This is not a general reaction. So below one is the general reaction. So that I am mentioning. Maybe you can look into that. What is this? Selenium tetrabromide. Selenium tetrabromide, when it is treated with alkyl mercuric compound, this is Hg, it is in the state of mercury. Means you know that Hg is having +1 state as well as the +2 state. It is a, so in this case it is a +2 state. So what is happening here? Selenium tetrabromide on reaction with selenium tetrabromide on reaction with mercuric alkyl compound in presence of aluminum chloride. So what is the obtained compound? The obtained compound is dialkyl selenide. Suppose R is an alkyl. If R is an aryl, then we can say that diaryl selenide. So overall, what you need to remember here, so a selenium tetrabromide. Selenium tetrabromide, when it is reacts with the alkyl or aryl mercuric compound in presence of aluminum chloride, it gives alkyl or aryl selenide. Okay, so this is a general method. If you want to take a particular one, maybe you can take dimethyl mercury, diethyl mercury. Okay, so diethyl mercury, when it is treated with selenium tetrabromide in presence of aluminum chloride, it gives dimethyl or diethyl selenide. Similarly, instead of taking a mercuric alkyl or a benzene, of course here aromatic selenide is obtained, and if R is equal to alkyl, this will be a what is called as aliphatic or alkyl selenide. And here, suppose if we are taking a alkyl halide, so Rx means alkyl halide, alkyl halide. So, what is the name of this compound? Disodium selenide. Disodium selenide, when it is react with alkyl halide, it gives dialkyl selenide. Similarly, I think you are aware about the sodium sulfate. What is the, how many oxygens are there? I think Na2SO4, isn't it? Na2SO4 is a sodium sulfate. Suppose one of the oxygen is attached with the methyl, then what you can say that? Methoxy sodium sulfite. So what will happen here? So the I think you know that Se in this Na2SO4, it is Na2Se, it is available in the form of anion. So that anion react with this methyl group. Now in this methyl is a electron deficient one. So that means there will be a reaction between the selenium and the methyl. So what is the compound obtained? Selenium dimethyl selenide is the compound. So this is an example. So above one is the general reaction. Above one is the general reaction. So below one is the particular example. Okay. So this is about what is called as preparations of organoselenium compounds. So with this, I will go to the next slide. So next slide, will give you the information about physical properties and chemical properties. So if we are looking into the physical properties, so these are generally solids. So that means organoselenium compounds are generally solids. And the color of the organoselenium compound varies from orange to yellow color. And the melting point is greater than 100 degrees Celsius. Melting point of the organoselenium compounds, it's greater than 100 degrees Celsius. And it is found that stable at room temperature. So what is the room temperature? Room temperature in Bangalore at present it is 25 degrees centigrade. So normally room temperature also mentioned variation. So in one place it will have a certain temperature, in other place it will have a different temperature. Okay. So room temperature at present in our college it's around 25 degrees centigrade. So then chemical properties. So chemical properties. So let's look into the chemical properties. So more particularly, we will what will happen when organoselenium compounds is treated with alkyl halide. This is one aryl alkyl halide. So aryl alkyl halide. So example for aryl alkyl halide is benzyl chloride, benzyl bromide, benzyl iodide. So here I am taking a benzyl bromide. So this benzyl bromide, when it is treated with uh, phenyl sodium selenide, phenyl sodium selenide. So what will happen? Na and Br, Na and Br will go out as a byproduct. And then what is the new product? New product, there will be a new bond formation between this carbon and this selenium element. So that is how a compound is obtained. Now what is the name of this compound? So you can observe that phenyl CH2 is called benzyl group and this is phenyl group. So benzyl phenyl selenide. Benzyl phenyl selenide is the name of this compound. And this moiety, when it is treated with LDA, I think you are aware about LDA. So what is LDA? LDA is a lithium diisopropyl hamide. So in your previous semester, we discussed about the synthesis and application of LDA in organic synthesis. So in this case also, what is happening, you know that adjacent to the selenium, there is a carbon. This carbon is called alpha carbon. This carbon on treatment with LDA, there will be a formation of anion on this carbon. That anion can react with electrophile. What is electrophile here? Ethyl bromide is electrophile. So what will happen? There will be a new bond formation between this carbon and this carbon. So that is how a compound is obtained. Okay. So from here to here, what you need to remember, LDA is a base. It will attack this proton, capture the proton, forms an anion. That anion attack this electrophile. Br is going out. So a compound is obtained like this. So this compound on treatment with sodium hydroperoxide. So the combination of sodium hydroxide and hydrogen peroxide, the obtained one is called sodium hydroperoxide. The sodium hydroperoxide is more reactive compared to the hydrogen peroxide. So what is happening here? It's an oxidizing agent. It converts selenium to selenium oxide. Sodium hydroperoxide is a oxidizing agent. It will convert selenium to selenium oxide. So I think maybe you are aware about the oxidations of peracids. So hydrogen peroxide is a peracid. Sodium peroxide is also a peracid. The role of peracids in organic synthesis. So in this case, selenium gets converted into selenium oxide. So once there is a formation of selenium oxide, so it will capture this proton. So what is the name of this proton? You can observe that this is a oxygen and this is a selenium and this is a alpha compound. This will be the beta carbon. So beta carbon and beta hydrogen. So that means O minus means oxide, means selenium oxide captures a proton, beta proton. So then what will happen? So there will be a new bond formation between this oxygen and this proton. And this bond pair is coming over here. And this bond pair, okay, the bond between the selenium and carbon breaks. Why it is breaking? Because selenium attains a positive charge when it is oxidized with hydrogen peroxide. So then what is the compound obtained? The compound obtained is called alkene. So what it means? So what you can take it from this? So with the help of organoselenium compound, it is possible to convert a phenyl means aryl alkyl bromide to an alkene. So that is the advantage. I think this kind, I think you can observe that here 2 electron. So 2 electron and 2 electron, 6 electron system. So wherever there is an involvement of 6 electron, those reactions are concerted reaction and those reactions are more feasible one. So this is about the one application or one method of synthesis of alkene using organoselenium compounds. So with this, I will go to the next slide. So in the next slide, I will take one more example and I will explain how the application of organoselenium compounds in the preparation of alkenes. Okay. I will go to the next slide. Right. So look here. Here, the starting material, what is called as phenyl methyl bromide. It's called benzyl bromide. The benzyl bromide, when it is treated with, this is a benzyl bromide. So what is this? Phenyl sodium selenide. Benzyl bromide, when it is treated with phenyl sodium selenide. So what is the product obtained? Byproduct is sodium and Br, and the product is benzyl phenyl selenide. So this formation we also discussed in the last slide. So what is the changes now? LDA is also a same. It's a base. It captures a proton here and forms an anion. And this anion react with cyclohexyl methyl bromide. Cyclohexyl methyl bromide. So that means here to the previous one, the difference is here. So after the formation of anion, the electrophile is different. So in the previous one, ethyl bromide is the electrophile, but here cyclohexyl methyl bromide is the electrophile. So then what will happen here? So look here. So cyclohexyl means C6H11 CH2Br. So to that CH2, this anion part is attacking, forming a compound like this. So once there is a formation of compound like this, so what is the name of this compound? This is a phenyl. Okay, right. So when this is oxidized using sodium peroxide, so where you can get the sodium peroxide? Combination of hydrogen peroxide and sodium hydroxide is called sodium peroxide. Okay. This sodium peroxide converts selenium to selenium oxide. Once there is a formation of formed selenium oxide, what it will do? It will capture the proton. The proton is called beta proton. So that means the proton present here, that is captured by O minus. Once there is a bond formation between this oxygen and this proton, this bond pair is coming over here. This bond pair is taken by selenium. So that is how phenyl selenic compound, a byproduct, is obtained, and this is a product, and this is a alkene. Okay. So this is about another application or another reaction of what is called as organo-selenium compounds. Okay. So then with this I will go to the next slide. So next slide I will explain how the organo-selenium compounds is useful in the preparation of allylic alcohol. So what is allylic alcohol? What is allylic bromide? What is phenyl bromide? So that I will discuss in the next slide. Okay. In the next slide, so this is the one. So what is so here I am mentioning preparation or synthesis of alpha, beta unsaturated carbonyl compounds. So what is alpha? This is a carbonyl compound. This carbon is alpha. This carbon is beta. Alpha, beta unsaturated carbonyl compound. Of course, this is an example of alpha, beta unsaturated carbonyl compound. So what is this? This is also a alpha, beta unsaturated carbonyl compound. What is the difference between this? So this is cyclopentadienone. This is also a cyclopentadienone, but the substituents are different. Okay. So then you can say that a alpha beta unsaturated carbonyl compound is converted into substituted alpha beta unsaturated carbonyl compound. But actually what we are talking, so we are talking about the role of organo-selenium compounds. So this organo-selenium compound, so what it will do, it will convert this moiety into this. Okay. So here this cyclopentadiene, when it is treated with phenyl lithium, so phenyl lithium, what it will do? pH minus means it's an anion. So where it will attack? It will attack this carbon, and this bond pair will go over here, and this bond pair picks up this lithium. So that's what I have written here. So at this stage, when this is treated with phenyl selenyl bromide. So when a bond between the oxygen and lithium is coming back, there will be a new bond formation between this bonded pair and this selenium. So that is how a compound is obtained. So this compound, you know that this proton. So what is the name of this proton? This proton is called methane proton, methyne. So methane proton. So methane protons are more acidic compared to methylene proton. So methylene protons are more acidic compared to the methyl proton. Methyl means CH3. So what is happening? So in presence of base, this proton can be captured and there will be an anion. That anion reacts with alkyl halide. So there will be a product formation like this. Once there is a product formation like this, so if this moiety is treated with hydrogen peroxide, hydrogen peroxide is the oxidizing agent. It will convert selenium to selenium oxide. Once there is a conversion of selenium to selenium oxide, there is a anion O minus and Se plus. This O minus captures this proton. Which proton it is? It is a beta proton. It means that there is a formation of bond between this oxygen and this proton. Then what it will do? The bond pair between this carbon and this proton is moves over here. When this bond pair is going over here, the bond between the carbon and selenium breaks. So that is how an alpha beta unsaturated ketone is obtained. So with this, I will take one more example. So that is I will go to the next slide. So look here. So this is a ketone. And you know that this carbon is called what is called as alpha carbon. The proton present here is the enolic proton. Why it is enolic? Because they are involved in a keto-enol tautomerism. And so here what is happening? pH minus. pH means phenyl anion can capture a proton present here, means alpha proton. When there is a capture of proton, what will happen? There will be a anion formation. That anion can come over here and this can fix up a proton. So that is how a compound is obtained. Means enol. This enol, when it is treated with phenyl selenyl bromide. So that means the bond between the oxygen and lithium bond pair is coming over here, and this bond pair form a bond with selenium and bromide is going out. It means that there will be a new bond formation between this carbon and selenium. So that is how a product is obtained. Once there is a product formation like this, so this on treatment with base. As usual, base what it will do? It will capture this proton. Once the base captures this proton, there will be a anion formation. So this anion attacks this compound. What is the name of this compound? This compound is called prenyl bromide. Prenyl means P-R-E-N-Y-L. So prenyl bromide. So where it will attack? Anion is attacking more particularly this carbon. Br is going out. So that is how a substituted product is obtained. At this stage, an oxidizing agent, hydrogen peroxide, is treated. What is the role of hydrogen peroxide? It converts selenium to selenium oxide. Once there is a formation of selenium oxide, the anion present on the oxygen captures this proton. Once there is a bond formation between this oxygen and this proton, The bond pair between this carbon and hydrogen is moves over here. When there is a electron movement from here to here, the bond between the carbon and selenium breaks. So that is how an alpha, this is alpha, this is beta, alpha, beta unsaturated carbonyl compound is obtained. Okay. So with this, I will go to the next slide. So what is the name of this compound? It's a naturally occurring compound. I think you are aware about the fatty acid. This is a fatty acid, a long chain carboxylic acid. Of course, there are a double bond. I think you are aware about the arachidonic acid. Arachidonic acid is a compound. It is present in groundnut. Okay. So what will happen here? You know that this is a carboxylic acid. This carbon is called alpha carbon. So when this carbon is treated with the LDA, what is LDA? LDA is a lithium diisopropylamine. It's an amide. It's a base. It captures a proton. Where it will capture a proton? This proton. What is the name of this proton? It's an alpha proton. Okay, alpha to the carboxylic acid. So what will happen once there is a formation of anion? That anion react with this selenium. So there will be a bond formation between this carbon and selenium. Then afterwards what will happen? The third step will be the treatment with hydrogen peroxide. Selenium oxide is formed and then deselenation. So that means there will be a new double bond formation here. So that's what I have written here. Okay, this is how a fatty acid is converted into unsaturated carboxylic acid. Okay, saturated means alpha beta unsaturated carboxylic acid is obtained. So with this, I will go to the next slide. In the next slide, I will explain about how one can synthesize a allylic alcohol. Okay, I will go to the next slide. So look here. It is an alkene. Allylic alcohol. What is allylic alcohol? OH. So this is a double bond and this is a OH. This type of molecules are called allylic alcohols. In short form, it's also called as a enol. Enol. So it is one alkene I am taking. It's a symmetrical alkene. So what will happen? A alkene, when it is treated with phenyl selenyl hydroxy group. So just like addition reaction, so Sc phenyl will add to one carbon, OH will add to another carbon. So that is how a compound is obtained. So this compound, when it is treated with tertiary butyl hydroperoxide. So tertiary butyl hydroperoxide is a peroxide. Its role is to convert a selenium to selenium oxide. Once there is a formation of selenium oxide, then there will be a capture of proton and there will be a bond pair movement. So this Se bond breaking. So that is how enol is obtained. So this is about the how allylic alcohol is synthesized with the help of the reagent called phenyl selenyl hydroxy group. Okay. So with this, I will go to the next slide. In the next slide also, I am taking one more example of allylic alcohol preparation. I think you are aware about this. It's a natural product. More particularly a terpenoid, a monoterpenoid. Of course, there is a double bond. To this double bond, phenyl-selenyl hydroxy group is added. SCPH will add to one carbon atom, OH will add to another carbon atom. So that is how a compound is obtained. Once there is a formation of compound, when it is treated with the tertiary butyl hydrogen peroxide, selenium gets converted into selenium oxide. This selenium oxide captures a proton. There will be a bond pair movement and there will be a breakage between the carbon and selenium. So that is how enol is obtained. So this is about what is called as the organoselenium compound and their application in the preparation of alkene, alpha beta unsaturated ketone and allylic alcohols. Okay, so maybe if you have any doubts, you can ask me. If there are no doubts, what you can do, maybe you can